Problem 3 is false. The only way an OR statement can be false is if both parts of it are false. Problem 9 asks us to do a compound OR statement between the negation of P and Q. So I've started off with two statements, P and Q. I've done true, true, false, false, and true, false, true, false for P and Q. That's standard. That's what we should always do. The negation of P then would be false, false, true, true. The negation of Q would be false, true, false, true. Now the only way an OR statement can be true is if one or the other or both parts are true. And that happens here, here, and here. Here is the case that was talked about in problem 3, where both parts of our OR statement are false. In that case, the OR statement is false. So this is kind of the result of the problem. It's the result of the truth table. It tells us about whether or not this compound statement is true or not, and it tells us the conditions that make it true. For instance, if P and Q are both true, then this compound statement is false. If P and Q are both false, then this compound statement is true, etc. In 13, we're asked to complete a truth table for this compound statement here. We're needing a P and an R, which we already have. We need a not Q, so let's put in a not Q. It's the opposite of the Q's, so it would be false, false, true, true, false, false, true, true. Then we need to combine these two with an OR statement, so let's do that next. That'll be not Q or R. Not Q is here or R is here. The only way an OR statement can be false is if both pieces are false. So I like to look around for both of these being false. Here's one case where they're both false. Here's another case where they're both false. Double check. I think I see a true in each of the others. And so we have this. But now we need to do an OR with P or this statement. So we have P or this statement, not Q or R. And not Q or R is here, and P is way over here. So I'm combining these and these with an OR statement. And the only way an OR statement is ever going to be false is if both parts are false. That can't happen when this is true. It can only happen down here, and I only see it happening once. And so that's false, and the rest should be true. Similar to the last problem, here in problem 17, we're trying to do a truth table for this compound statement. I need a not P and a not Q, so I'm going to put those in. Not P and a not Q. Not P is the opposite values of P, so we have 4 falses and 4 trues. Not Q are the opposite values of Q, so we have false, false, true, true, false, false, true, true. Now I need an R or not P, so R or not P. The R's are here, and the not P's are here. And what's the thing about an OR statement? The thing is, the only way it can be false is if both pieces are false. And so we have both pieces being false here. We have both pieces being false here. And that is it. So the rest of these are true. Now we need to combine that previous statement that we just looked at. We need to combine it and do an AND with not Q. So now we're going to use this, and we're going to use an AND with this. Now what's the thing about AND statements that stands out the most? And that is, the only way an AND statement can be true is if both pieces are true. Well, here the first piece is false, so these can never be true. Here we have a true, true. Here we have a true, true, and a true, true, and a true, true. I apologize, I circled the wrong one. In our compound statement, we have these, but we also have not Q, and that's these. So we should be looking at these two and putting in true and false values there. An and can only be true if both parts are true. And so we have a true, and a true, and the rest of these are false. And we're done. In problem 25, I've set it up, but we have P or Q or R. That's a compound statement made out of three simple statements, but they're all connected with ors. Remember, the salient fact, the key idea of an or statement is that the only way it can be false is if all the parts of it are false. So down here, where all three parts of it are false, then our compound statement is going to be false. If there's at least one true in it, it's going to be true. And so I'm not even sure it was worth writing down this truth table because we know what it's going to look like. It's not a big surprise, but there it is. Anyway, here we don't need to do the full 8-row truth table because we only need to have 2 of the rows, and why write down 8 if we only need 2 of them? So armed with the conditions that P, Q, and R are true, false, and true, we can start filling in these things and see what we have. So we have not P, that's not true, that's false, and not Q, that's true, or not R, R is true, so not R is false. False and true gives us false, and we have false or false, and that is false. Similarly, here we have not P, P is false, so not P is true, and we have not Q, Q is true, so not Q is false. And then we have or, and then we have not R, R is true, so the negation of R has to be false. True and false is false. False or false is false. So both of these compound statements are false. This one's false given these conditions for P, Q, and R. And this is false given these conditions for P, Q, and R. Problem 53, we're given the words for the simple statement, and then we're given a compound statement that we're asked to translate. The statement is Tanisha owns a convertible and Joan does not own a Volvo. And so we have P and not Q. And so we need to construct a truth table for P and not Q. We start out the same way that we always start out a truth table with 2 statements. And we're going to need a not Q. And so false, true, and then we need to do an and between the P column and the not Q column. And the only way an and can be true is if both parts are true. And so we have P and not Q. And here both parts are true. The rest of the rows have at least one false. And so this is the result of the truth table. Of course, our textbook adds that case 2, meaning row 2, is the place where we have a true, so that would be case 2 or row 2. But to me, for now, the idea is we have all the different values, false, true, false, false, depending on the beginning conditions of P and Q. And I will not ask you to tell me something like which cases make it true.